have you heard of like quantum mechanics as a whole? Have you heard of the many worlds interpretation?
I've heard of it. I haven't really read that much about it.
So my understanding of it is basically like, Schrodinger's cat.
Mm-hmm.
So the idea that, you take a particle that can be in like an upspin or downspin, right? And then let's say it's up, it causes this radioactive, or it causes some chemical to spill that kills the cat in the box.
Mm-hmm.
It spins down, the chemical doesn't spill. Mm-hmm. So basically the idea is taking quantum superposition and expanding it to a macroscopic object. So now the cat is, for all intents and purposes, in superposition until you open the box, right? So the cat's either dead or alive. So that's like the base. That's what like most people know if they know about quantum mechanics. But then the many worlds interpretation is essentially, well, how are we any different from the cat in the box? So imagine I'm standing over the box. I'm a scientist. Mm-hmm. But then I'm in a room with no windows and there's a door and someone's standing outside the door. So now to that person, I'm in a superposition of seeing the cat alive, seeing the cat dead. Mm-hmm. So then it just keeps expanding. And the idea is that the whole universe gets like stuck into this superposition, right? So this is where like the whole fundamental principles come in, because there's a ton of math to this theory that I don't understand. But apparently somehow the math works out, or seems to work out, in which every time there's like a superposition and then it decoheres, for example, it like is an up or down state, like the universe kind of branches. Mm-hmm. So there's one where it's up and one where it's down. And it's actually kind of funny because there's this app. Do you know who Sean Carroll is? He's like a pretty popular guy in quantum mechanics, and he has like a podcast and stuff. He has this app where it's called the Universe Splitter. And I put
the Universe Splitter.
Yeah, so let's say I'm deciding if I should go to the gym or stay home and watch TV. I put the two options down, and then I click OK. And then it sends a signal to a lab in Switzerland, Geneva, Switzerland. Yeah. And it fires an electron, it measures it up or down, and assigns the options to up or down. And then it sends me back a signal. It's like, you were in the universe where you stay home and watch TV. Right. And the idea is, based on the theory, there's another universe where instead I go to the gym. Probably a more productive universe for me. Right?
That was crazy.
So there's something... There's basically... Basically, I just thought it was cool. It's a cool theory. And it's interesting that if it's true, like quantum computers in some sense take advantage of that, like this idea that these particles can go through multiple universes in some sense.
That's the coolest part. Like when you think about it, it's like, what are computers? What are like even quantum computers, right? Yeah. We're just like taking advantage of like whatever properties our universe has and just making use of them, and it's helpful for like that's what's the cool part of like engineering for me. Like just being able to see, it's hard. Like, how you said, like, there's a ton of math involved to get to the macroscopic. Like, someone did the math. Someone figured it out. Like, there was, like, something to be discovered there. That's just amazing.